It's basically writing down what the simple harmonic oscillator would be. With slight modifications. Suppose you have a spring system where you have a single mass m that has springs on both sides. The left spring and right spring both have spring constant k. Find the equation that governs the motion from Newton's second law. What's the solution? Okay, so let's basically draw a picture first. You have basically two springs. Let me just check one thing. Two springs. This is spring 1, which has a spring constant k. You have a mass m in the center, and then the spring on the right. Again, with also a spring constant k. We're going to assume it's attached to two walls, basically on the left and the right side. All right. So the forces on this thing involve basically there's a force from this spring, which I'll call F1, which is going to be minus kx, all right, where this is the x equilibrium point, okay? And then the force F2, which is going to be basically on this side, right, which is also going to be minus kx, all right? So it turns out that this is the sum of the forces in the x direction is F1 plus F2, right? So this is just simply going to be equal to minus kx minus kx, which is minus 2kx. All right. First, it's actually rather obvious why this is the case, because if you put two springs which are the same on both sides of something, basically what will happen is that you have basically double the spring force. Okay, now this is the net force, which is also equal to the mass times acceleration, and that we know is going to be m dx squared dt squared is equal to minus 2kx, or m d squared x dt squared plus 2kx equals 0. Just basically adding both sides. So this is the equation, or this is the equation that governs the motion. Now, how do we solve these equations? Well, we already know, basically, from a simple harmonic oscillator, the solution to this equation, dx squared dt squared plus k over m, x equals 0. The solution is x of t is equal to a cosine of omega t plus delta, where omega is equal to k over m, the square root of that. Okay, well, simply it's the same pattern, all right? We just divide by m here, divide by m, right? The only replacement I have is basically 2k, km becomes 2k over m, right? So the solution is simply going to be x of t is equal to a, again, cosine of, now let's just put this omega in, square root of 2k over m t plus delta. Okay, just basically matching the pattern and then basically making the substitution. All right, hope that was helpful.